Hello grade 12s and welcome back to another video. In this video we will be looking at question number 5 of the November 2021 Physical Science Paper 2 exam. This question deals with rate and extent of reaction. The question says the reaction of 15 grams of an impure sample of calcium carbonate CaCO3 with excess hydrochloric acid HCl of concentration 1,0 mole per decimeters cubed is used to investigate the rate of a reaction. The balanced equation for this reaction is as follows. The volume of the carbon dioxide produced is measured at regular intervals. A sketch graph representing total volume of carbon dioxide gas produced as a function of time is shown below. And over here we have a graph of volume versus time. Before we go on to the other questions or the questions that follow, I would like us to analyze the information that has been given to us. Number one, I would like to point out that calcium carbonate and the hydrochloric acid are the only two reactants in this reaction. The hydrochloric acid is in excess. This indicates to us that the calcium carbonate, specifically the pure calcium carbonate in the impure sample, is going to be the limiting reagent. We remember that since this is an impure sample, we may not use the 15 grams in our stoichiometric ratio, so we can't convert this to number of mole and then use that number of mole in the stoichiometric ratios because it is an impure sample. Now, they say that the hydrochloric acid that is used is of a certain concentration, so we know the concentration of the hydrochloric acid. Since this question deals with rate and extent of reaction, I would like to remind you of the factors that influence rate of reaction, and I want us to take a look at the equation to understand what is going on. There are 5 factors that influence the rate and extent of a reaction. Firstly, we have the nature of reactants, then we have temperature, concentration of gases and aqueous solutions, only gases and aqueous solutions. We have the surface area of solids and the addition of a catalyst. Now, if we look at the reaction that is taking place, we can see that calcium carbonate is a solid. That is very important information. The hydrochloric acid is aqueous. The calcium chloride is aqueous. The water is a liquid and the carbon dioxide is a gas. Please do not ignore the phases in which the different reactants and products are in. These are important because they relate to these factors that I just mentioned. We can now go on to the questions. Question number 5.1 says, define the term reaction rate. Now we have a few options here. The most common one that we write down is change in concentration of products or reactants per unit time. And for writing that down, you're going to obtain 2 marks. Alternatively, you can say it is the change in the amount or number of moles, volume or mass of products or reactants per unit time. You can say it is the amount, number of moles, volume, mass of products formed or reactants used per unit time. Or you can say it is the rate of change in concentration or amount of moles, number of moles, volume, or mass. I would go with option number 1 with the very first bullet point because this is the definition that we most commonly make use of, and as you can clearly see, it is the shortest and simplest version of this definition. Question 5.2 says, give a reason why the gradient of the graph decreases between time 2 and time 3. If we go up to the graph, we can clearly see that at first the gradient is very steep, and then it becomes even steeper. But between time 2 and time 3, we see that the gradient becomes less steep. What is happening is that as time goes by, the amount of carbon dioxide that is being produced decreases. And this is, of course, because the reactants are being used up. The concentration of the reactants is decreasing, and therefore the rate at which carbon dioxide is produced is decreasing. So here we had a few options. For 1 mark, you can say the reaction rate decreases. We know that gradient is the indication, or a gradient of a graph like the one given to us indicates the rate of a reaction. So we can say the reaction rate decreases. We can say the concentration of hydrochloric acid decreases. We can say it is the concentration of the hydrochloric acid, but grade 12 is very important. We cannot say it is the concentration of the calcium carbonate. If you said the concentration of the calcium carbonate decreases, you're not going to obtain your mark. And the reason for this is because calcium carbonate is a solid, and solids do not have concentration. So please make very sure that you only speak of the concentration of aqueous solutions and gases. Another option is to say that the concentration of the reactant decreases. If you look carefully, you will see that they mentioned the reactant, not reactants, because it is only one of the reactants that has concentration, specifically the hydrochloric acid. They say the reactants are used up. Or you can say the mass of the calcium carbonate decreases or is used up. Any one of these will get you your 1 mark for question number 5.2. Question 5.3 says, changes in the graph between time T1 and T2 are due to temperature changes within the reaction mixture. The word within is very important here because it explains that we, as observers, as the external environment, are not adding more heat or removing heat from the system. Instead, what is happening is that bonds are being broken and new bonds are forming. When bonds break, energy is absorbed. So we absorb energy, or the molecules will absorb energy in order to break bonds, and energy will be released when bonds form. So the question is, within this reaction that is taking place, is there going to be a net absorption of energy or a net release of energy? But again, we are speaking about what is happening within this reaction. It is not heat that is being added or removed by the external environment. Question 5.3.1 says, is the reaction exothermic or endothermic? We know that an exothermic reaction will be one where there is net energy being released, and therefore the temperature will become higher. An endothermic reaction has a net absorption of energy, and therefore the temperature of this reaction mixture will become colder. Let's go and take a look at the graph to see what happens between time T1 and T2. We see that there is a sharp increase in the gradient of the curve between time T1 and T2. If the gradient increases, it means that the rate of the reaction between time T1 and T2 increases. Now, in terms of temperature, when will the rate of reaction increase? Is it when the temperature increases or when it decreases? Rate of reaction will of course increase if the temperature increases, because an increase in temperature means that the particles have more kinetic energy so that they can collide more effectively, with enough energy to react and become the products. So we know that in order for this change to take place between T1 and T2, the temperature needs to increase. So if we now go to answer this question, increase in temperature means that the reaction is exothermic, and we write this down for 1 mark. Question 5.3.2 now says, explain the answer by referring to the graph. Whenever you are required to give an explanation, I do advise that you always write down your explanation in bullet point form so that you can see which point you are making in order to obtain your marks. This question is out of 3 marks, which means we need 3 valid points. They say we need to refer to the graph. Okay, very important here. This reaction is one that only happens forwards, so it is only that way in which this reaction takes place. This is not a reversible reaction, and therefore, to answer this question, question 5.3.2, we will not be making use of what we learned about chemical equilibrium, neither will we make use of Le Chatelier's principle. So firstly, we write down what we saw when we looked at the graph. We saw that the gradient increases, or we could say it becomes steeper, or we can say the curve becomes steeper. For writing down what we see, we are going to obtain 1 mark. Now we interpret what we saw. We know that the gradient increasing means the reaction rate increases, or you can say more or larger volume of carbon dioxide is produced per unit time. The word per unit time is very important because that emphasizes that we are dealing with reaction rate. If you just say more carbon dioxide is being produced, then you are not referring to the rate of the reaction. Please make sure that in this section you never leave out the words per unit time. So that is going to get you your 2nd mark, the interpretation of what we see when we look at the graph. Now we say that this means that the temperature increases, or we can say energy is released, or the average kinetic energy of the molecules increases, and that is going to get us our 3rd mark for question 5.3.2. Question 5.4 says, the percentage purity of the sample is 82.5%. Calculate the value of X on the graph, assuming that the gas, that is the carbon dioxide gas, is collected at 25 degrees Celsius. Take the molar gas volume at 25 degrees Celsius to be 24,000 centimeters cubed. We are used to the molar gas volume given to us at STP as 22.4 decimeters cubed. But over here they say that we are using a different molar gas volume. Specifically, we are taking the molar gas volume at 25 degrees Celsius to be equal to 24 decimeters cubed. And this is the value that we're going to be using instead. Please read your questions carefully and use the values that have been given to you. So in order to determine the amount of carbon dioxide that is going to be collected or produced, we first need to go to the graph and see what exactly is happening at X. If we look at X, we see that this is the, time or the part of the reaction where the reaction is complete. So the maximum amount of carbon dioxide has been produced based on how much of the calcium carbonate within the impure sample is pure. So the pure calcium carbonate is going to react completely with the hydrochloric acid to produce this carbon dioxide. We would like to know what is the maximum amount of carbon dioxide that can be produced. I'd like to remind you that the mass of the impure sample of calcium carbonate is 15 grams. The concentration of the hydrochloric acid is 1.0 mole per decimeters cubed, and here we have the balanced chemical equation, and we are always interested in this because the balanced chemical equation allows us to perform stoichiometric calculations. Please ensure that whenever you are answering questions of this nature, that you label all of the values that you're writing down. For example, over here, I've indicated that we are dealing with the mass of calcium carbonate. Here we are looking at the concentration of hydrochloric acid. So either include these names in brackets or use them as subscripts. Remember, the person who will be marking your test, your exam, the teacher will be marking your exam at the end of the year, is not your own teacher. So he or she is not familiar with your way of writing down or answering questions, and therefore you need to complete your exam in a way that will make it easiest for the marker to understand what is going on. If you do not do so, you may end up losing unnecessary marks. So please be sure to do so. So number one, we're going to start off by determining the amount of pure calcium carbonate in this impure sample. We say percentage purity is going to equal to the amount of pure substance over the sample multiplied by 100. So in this case, the percentage purity has been given to us as 82.5. We would like to determine the amount of pure substance in the sample. The mass of the sample is 15 grams, and we multiply that by 100. When we solve for the mass of pure calcium carbonate, we find that the mass of the pure calcium carbonate, and we're going to mark this as pure, is going to equal to 12,375 grams. Now please remember, you may not use the 15 grams to perform your stoichiometric calculations. Instead, you're going to be making use of the pure sample. So now that we know the mass of the pure calcium carbonate, we're now going to go a step further and determine the number of moles of pure calcium carbonate. We write down the formula. Number of moles is equal to mass divided by molar mass. This is going to be the number of moles for the calcium carbonate, so we make sure to label this as calcium carbonate. So now we say 12,375. Notice that I did not round this value off because we have not reached the final answer. We do not round off our answers until we get to the final answer in a question. Divided by 100 because the molar mass of calcium carbonate is 100, and this is going to give us an answer of 0.124 moles of calcium carbonate. We're not done yet. We would like to determine the volume of the carbon dioxide produced. We are looking for V of the carbon dioxide. So now, since we have the number of moles of calcium carbonate, we can say the substances or the calcium carbonate's ratio is 1. The amount of carbon dioxide that will be produced when 1 mole of calcium carbonate reacts is 1 mole. So therefore, if we are looking at the ratio of calcium carbonate to carbon dioxide, we see that the ratio is 1:1. Therefore, grade 12, the number of moles of carbon dioxide that are going to be produced, or that is going to be produced, is 0.124 moles because the ratio is 1:1. Now we would like to determine the volume of the carbon dioxide that is produced. This specifically is volume X. We remember that to calculate volume, we can say number of moles multiplied by the molar gas volume. The number of moles here is 0.124. The molar gas volume is the molar gas volume that has been provided to us, which is 24 decimeters cubed. Please do not use 22.4. When we plug this into our calculators, we find out that the final answer is 2.98 decimeters cubed, and you're more than welcome to round this off because it is the final answer to this question. In an answer, in a question like this, you're going to get your marks as follows. Number 1, you're going to get a mark for the method that you use to determine the mass of the pure calcium carbonate. Number 2, you're going to get a mark for showing how you calculated the number of moles of calcium carbonate. Number 3, you're going to get a mark for stating that the number of moles of carbon dioxide is equal to the number of moles of calcium carbonate, since the ratio is 1:1 according to the balanced chemical equation. Number 4, you're going to get a mark for your substitution into the formula to calculate the volume of carbon dioxide. And the 5th mark you are going to obtain for your final answer. Now, grade 12s, if you have a look at your marking guidelines, you're going to see that there are two other options that you can use to calculate the answer to this question. Please go and have a look at those, or if you have a different method, try it first and then check the exam guidelines to see if you're on the right track and to see how many marks you would obtain for a question like this that is out of 5 marks. A question like question 5.4 is actually a grade 11 question because you learned about percentage purity and all quantitative aspects of chemical change in grade 11. So if you found this question to be challenging, perhaps you need to take a step back and revise your grade 11 quantitative aspects of chemical change. I would just like to remind you that on your formula sheet or attached to your formula sheet is table number 1, where you will see the physical constants. For example, we have the molar gas volume at STP given as 22,4 decimeters cubed per mole. If we look below that on the formula sheet, we see the actual formulae. In this question, we made use of this formula and we made use of this one. Please remember that this formula is reserved for gases, while this on the left is for aqueous solutions where we are dealing with concentration. I often find that learners confuse those formulae on the left with the one on the right for gases. Please don't make that mistake. Question 5.5 says, how will the reaction rate change if 15 grams of a pure sample of calcium carbonate reacts with the same hydrochloric acid solution? Choose from increases, decreases, or remains the same. So at the beginning of this video, I reminded you of the factors that influence rate of reaction. We were also given a balanced chemical equation where we saw that the calcium carbonate is in solid form. So when we are dealing with solids, we know that we must refrain from using the term concentration because concentration is reserved for gases and aqueous solutions. When we add 15 grams of calcium carbonate instead of the original 12,375 grams, what we are doing is that we are adding more calcium carbonate. And if we add more calcium carbonate, then we are increasing the surface area of the solid. If the surface area is higher, so if we have a larger surface area for the calcium carbonate, then of course the reaction rate is going to increase. There is more space for the hydrochloric acid particles to interact with the calcium carbonate and for effective collisions to take place. Well, more effective collisions to take place per unit time. So for writing down the word increases, you're going to get 1 mark. We're now on question 5.6, which is the very last problem in this video. It says use the collision theory to explain the answer to question 5.5. This question is out of 2 marks, which means that we need to make at least 2 valid points. And again, I do encourage you to use bullet points when answering questions like this. Firstly, we need to state what adding more calcium carbonate does in terms of the factors that affect rate of reaction. So we say adding the 15 grams of calcium carbonate will give us more calcium carbonate particles being exposed. Or we can say it will result in a greater exposed surface area, and that will give us the first mark. The second mark comes from stating that this will result in more effective collisions per unit time or a higher frequency of effective collisions. Very, very important is that you do not leave out the word per unit time. Just more effective collisions does not mean that the reaction rate increases. We need to include the word per unit time, and we then get the second mark. So this brings us to the end of question number 5, which is out of 15 marks. In the next question, question number 6, we will take a look at a problem involving chemical equilibrium. Please join me in that video.